In the realm of space exploration, some challenges seem insurmountable. Among them stands the fully reusable heat shield, a puzzle that has stumped aerospace engineers for decades. Yet in a recent announcement that sent shockwaves through the space community, Elon Musk revealed SpaceX's boldest ambition yet: mastering this technology by 2025. A truly reusable orbital heat shield has never been made, Musk stated, his words carrying the weight of both challenge and promise. But why is this seemingly simple component so crucial? Picture this: 18,000 interlocking tiles, each one vital to protecting spacecraft from the inferno of atmospheric re-entry. Every tile must perform flawlessly, not just once, but multiple times, with minimal maintenance between flights. The stakes couldn't be higher. Previous test flights have shown the brutal reality of re-entry, with tiles breaking or falling off. But SpaceX isn't just accepting these limitations. They're revolutionizing the entire approach. From enhanced pin systems to innovative blade layers, from ceramic to metallic shields, every failure has led to a breakthrough. Recent developments suggest we're on the cusp of something extraordinary. The red tiles appearing on Starship S-35's nose cone, the successful re-entries of recent missions, and SpaceX's ambitious testing schedule all point to one conclusion: the impossible might just become possible. Welcome back to Elon Musk 24 Hours, where today we're diving deep into how SpaceX plans to achieve what many thought impossible: a fully reusable heat shield that could transform space travel forever. Let's dive right in. The journey to a fully reusable heat shield isn't just about technological advancement. It's about transforming our access to space itself. Let's break down why this development is so revolutionary and how SpaceX plans to make it happen. Think about the current state of spaceflight. Every time a spacecraft returns from orbit, its heat shield tells a story of survival. The shuttle's ceramic tiles, each one carefully inspected and often replaced after every flight. The countless hours of maintenance, the meticulous attention to detail, and still the constant worry about damage during re-entry. This is the reality that SpaceX is determined to change. What makes SpaceX's current approach different? It starts with the numbers. 18,000 tiles, each one designed to withstand temperatures that would melt steel. But it's not just about surviving the heat. It's about doing it again, and again, and again. The holy grail of spaceflight: true reusability. The evolution of SpaceX's heat shield technology reads like a thriller, with each test flight revealing new challenges and opportunities. Early attempts saw tiles falling off during flight, a heart-stopping sight for engineers and observers alike. But with each setback came innovation. The pin system that holds the tiles in place underwent multiple iterations, each one stronger and more reliable than the last. The material composition of the tiles themselves evolved, incorporating lessons learned from each mission. But the real game changer came with the introduction of the blade layers. These innovative components serve as a backup system, adding an extra layer of protection during the brutal re-entry process. It's like having an insurance policy against the extreme conditions of atmospheric re-entry. The effectiveness of this system has been proven in recent flights, where successful re-entries were achieved despite the incredible stresses placed on the vehicle. Now SpaceX is taking things to the next level. The metallic heat shield Musk mentioned isn't just an incremental improvement, it's a complete paradigm shift. Traditional ceramic tiles are inherently brittle, but a metallic shield could offer unprecedented durability. This isn't just theoretical. SpaceX has already begun testing these new materials under extreme conditions. The integration of advanced cooling systems marks another leap forward. By utilizing water, methane, or nitrogen, these systems could actively manage the extreme temperatures during re-entry. This approach moves beyond passive heat resistance to active temperature control, a fundamental shift in how we think about thermal protection. The red tiles recently spotted on S-35's nose cone tell us something crucial about SpaceX's progress. These aren't just cosmetic changes. They represent significant material improvements, likely incorporating lessons learned from previous flights. Each new iteration brings us closer to the goal of immediate reusability. But here's where things get really interesting. SpaceX isn't just developing this technology for Earth orbit. The company has already begun testing heat shield designs specifically for Mars missions. Recent test footage showed a new version of the shield enduring conditions even more extreme than Earth re-entry. This isn't just about making spaceflight more efficient. It's about making interplanetary travel possible. The timeline Musk laid out is ambitious but grounded in real progress. By the end of 2025, SpaceX aims to conduct up to 25 flights. Each one of these launches provides an opportunity to test and refine the heat shield technology. The company's rapid prototyping approach means that improvements can be implemented quickly, with each iteration building on the lessons of the last. A critical piece of this puzzle is the transition from ocean landings to catch landings using the Mechazilla arm. While ocean landings have served their purpose in early testing, they're not ideal for rapid reuse. Saltwater exposure means more intensive refurbishment between flights. The Mechazilla catch system, set to be tested as early as Flight 8, represents a crucial step toward true rapid reusability. The challenges ahead are significant. For the heat shield to achieve full reusability, multiple systems must work in perfect harmony. The flaps must provide precise control during re-entry. The engines must fire at exactly the right moments. The navigation systems must guide the vehicle to an exact point in space. And through it all, the heat shield must maintain its integrity. But SpaceX has been methodically checking off these challenges one by one. Flight 5 demonstrated successful booster catching with the Mechazilla arm. Flight 7 will push these capabilities further, testing both booster recovery and ship landing. Each successful mission builds confidence in the overall system. The implications of this technology extend far beyond SpaceX. A truly reusable heat shield could revolutionize the economics of spaceflight. Currently, extensive refurbishment between flights adds significant cost and delay. Eliminate that need, and you fundamentally change the game. Satellite deployment, space tourism, cargo delivery to orbit, every aspect of space operations becomes more accessible. As we look toward early 2025, SpaceX's Falcon 9 program continues to demonstrate the company's commitment to advancing space technology. The upcoming lunar missions, including the Blue Ghost mission and the IM-2 mission, will provide valuable data about spacecraft protection during deep space returns. These missions, while not directly related to Starship's heat shield development, contribute to the overall understanding of thermal protection systems. The integration of all these elements, the enhanced pin systems, the blade layers, the metallic shields, the cooling systems, and the precision landing capabilities, represents one of the most ambitious engineering projects in human history. But SpaceX has shown time and again that they can turn ambitious goals into reality. The journey from those first failing tiles to a fully reusable heat shield parallels humanity's broader journey in space exploration. Each setback teaches us something new. Each success builds upon previous achievements. And step by step, what once seemed impossible becomes routine. As we watch these developments unfold, we're witnessing more than just technological progress. We're seeing the foundations being laid for a future where space travel is as routine as air travel. A future where the limitations of traditional heat shields no longer constrain our ambitions in space. A future where the dream of regular, reliable access to space becomes reality. The next few months will be crucial. With multiple test flights planned and new iterations of the heat shield ready for deployment, we'll soon see if SpaceX can deliver on these ambitious goals. But one thing is certain. The progress we've seen so far suggests that we're on the cusp of a genuine revolution in spaceflight technology. The race to perfect a fully reusable heat shield represents more than just technical innovation. It's the key to unlocking humanity's spacefaring future. SpaceX's planned achievements for 2025 and 2026 could fundamentally transform how we approach space travel, making frequent launches and returns not just possible, but routine. As we've explored today, the combination of enhanced pin systems, innovative blade layers, and the potential transition to metallic shields shows that SpaceX isn't just dreaming big, they're methodically solving each challenge, one breakthrough at a time. The upcoming test flights will be crucial in proving these technologies, potentially marking 2025 as the year when true reusability becomes reality. Stay updated on this revolutionary journey by subscribing to Elon Musk 24 Hours. Drop a comment below with your thoughts on which development you think will have the biggest impact. The metallic shield technology or the advanced cooling systems? Don't forget to hit that like button to help more space enthusiasts discover this incredible story. Until next time, keep watching as history unfolds before our eyes. Breaking news from Starbase, Texas. SpaceX's Starship stands ready for its most ambitious flight yet. Flight 6 represents a pivotal moment in spaceflight history, with teams working around the clock to prepare for a launch that will showcase just how far this revolutionary vehicle has come. The days of concrete tornadoes and ground-digging launches are behind us, replaced by sophisticated engineering featuring a water-cooled steel plate that can handle the immense power of Starship's Raptor engines. The stakes are higher than ever. Pad B's rapid construction promises to double launch capabilities, while 2025's aggressive flight schedule signals SpaceX's confidence in Starship's reliability. As competitors scramble to catch up, from Blue Origin's latest developments to new players entering the reusability game, it's clear that Starship is already reshaping the future of space travel. Welcome to Elon Musk 24 Hours. Let's dive right in. At Starbase, dawn breaks over a scene that feels more like science fiction becoming reality. The launch mount, bearing the scars of previous launches yet standing prouder than ever, represents humanity's relentless push toward the stars. The morning silence breaks as the water deluge system roars to life, sending a massive torrent skyward in a final test before Flight 6. Engineers watch intently, knowing this innovative system, resembling a powerful industrial fountain, is all that stands between success and potential disaster when 33 Raptor engines ignite with the force of a small nuclear power plant. The real drama unfolds high above the Texas coastal plain. Teams of technicians, suspended at dizzying heights, work with precision that would impress the most skilled surgeons. They're reinforcing the booster quick disconnect housing, a critical component that's faced brutal battles with superheated gases in previous launches. Each weld represents a lesson learned, each modification a step toward perfection. The stakes couldn't be higher. A single weak point could compromise the entire mission. As the sun climbs higher, attention turns to what might be the most ambitious engineering feat in the entire Starship program: the Chopsticks. These massive mechanical arms, originally designed simply to stack the world's largest rocket, are being transformed into something far more sophisticated. Engineers huddle around complex hydraulic systems, making microscopic adjustments that could mean the difference between a successful catch and a catastrophic miss. The precision required is staggering. These massive steel arms must move with the delicacy of a watchmaker's tools while handling forces equivalent to catching a falling office building. The ship's quick disconnect system tells a story of perseverance and breakthrough. After every previous launch, this component emerged battered and broken, requiring extensive repairs that threatened to bottleneck the entire program. But something extraordinary happened after Flight 5. The system survived nearly unscathed. In the world of rocket science, such seemingly small victories can herald revolutionary changes. Engineers speak about it in hushed, excited tones, knowing they may have finally solved one of their most persistent challenges. Meanwhile, a second act in this grand production unfolds as Pad B takes shape. The construction site buzzes with activity as cranes pirouette through the air, removing temporary work platforms with balletic precision. The arrival of the Drawworks motor marks a crucial plot point. This repurposed oil rig technology represents SpaceX's genius for finding elegant solutions in unexpected places. The motor, seemingly modest in size, will control the movement of massive rockets through an intricate dance of cables and pulleys that would make Leonardo da Vinci proud. Below ground, another revolution takes shape. Crews excavate for a flame diverter system that promises to be even more sophisticated than its predecessor. This isn't just another construction project, it's a race against time to build infrastructure that can support the most ambitious launch schedule in human history. The complexity of the system serves as a reminder that even as Starship pushes the boundaries of space travel, it must first conquer the challenges of Earth. Inside Megabay 1, Booster 16 grows like a metallic tree reaching for the sky. The construction process resembles a symphony, with teams working in coordinated precision to join massive steel rings into a structure that will one day pierce the atmosphere. 16 of 24 rings are complete, but this booster holds a secret.